Evidence Thread 1. The geometry that shouldn't be. Start with what the numbers refused to do. They refused to act random. We had the insider's cached pull, the pre-sanitized high-rise frame, and a mast cam crop the public never saw at full fidelity. We laid Patrick's Jupiter node ratios over Jezero's ridge like a stencil. The alignments didn't snap everywhere, real data never does, but they locked at intervals that shouldn't exist in wind-carved stone. Stakes first. If geometry repeats with precision, you're not looking at chance. You're looking at intention. And intention means either biology, long gone, or engineering, maybe not. Action. We measured distances between arctangencies along the shallow relief. Center-to-center separations clustered around a ratio of 1 to 1.618 to 2.618, within a 2% residual. Tri-Axial symmetry showed up as intersecting curves whose normals resolved 36 degrees apart, rolling across the surface like a woven pattern half buried in dust. When Supercam's microimager grazed the edge, you could see dust mounded along lines as if electrostatically pinned, not just slumped, obeying an invisible boundary. You can pull phi out of anything, the skeptics will say. True, if you cherry-pick. So we didn't. We ran a blind Fourier analysis on the edge-detected lattice using a window that doesn't know golden ratios from grocery lists. Peaks emerged at angular frequencies corresponding to 36 and 72 degrees. Then we rotated the frame 5 degrees and ran it again. The peaks held. Random geology doesn't keep its secrets when you tilt it. Meanwhile, something else was happening. A third-party image specialist, call her V, took the pre-scrubbed frame and applied a tri-axial Hoff transform tuned for circular arcs. She expected noise. She got 3 dominant families of arcs whose centers fell on a quasi-hexagonal grid distorted by terrain relief, not by erosion paths. When she ran the same transform on nearby dunes, the algorithm went quiet. Only the ridge sang. Impact, we're out of pareidolia territory. We're in the math sees it even when your eyes don't territory. And that matters because human brains love faces, algorithms don't. But there was one problem. The public reprocess smeared the very edges the math relied on. So V tried something different. She reconstructed the lighting by estimating the sun vector at the timestamp and subtracting diffuse scatter using a Lambertian model. The arcs sharpened in the cached data, then vanished under the public kernel. She wrote 2 lines in her notes. Edges persist under lighting normalization. And suppressed by deconvolution parameter change. That's not weather. That's a choice. To test whether wind erosion could mimic this, we built a toy model. Simulate sedimentary layers with varying hardness, run a directional abrasion field over thousands of cycles, add frost spallation. You get crenulated edges, polygonal fractures, occasional pseudo-circular scallops. What you don't get is coherent tri-axial symmetry, with phi-space separations that persist across changing incident angles. Counterargument set up. Okay, maybe this is just our sampling bias. Maybe we're measuring a subset that happens to look special. So we pulled control regions, 4 nearby ridges with similar slope and grain size, from the same high-rise orbit. We ran the same transforms, the same Fourier windows, the same ratio tests. Controls failed to produce sustained phi residuals under 5%. The ridge passed 3 times. Impact. The ridge's geometry stands out against its own neighborhood. If chance did this, it's selective. Meanwhile, a buried detail from Patrick's Jupiter work came back into view. His node maps didn't just love phi, they loved triband interaction, 3 repeating channels that share a phase relationship. When V overlaid concentric arcs, she found that every third arc aligned with tiny albedo shifts barely above noise. She almost deleted it. Then she rotated the overlay by 12 degrees to compensate for local slope. Alignment tightened. Triband markers. Faint, but there. This is where the hidden angle proved its point. The lattice only completed when the sun sat between 21 and 23 degrees above the horizon. Sol Y, hour Z, the window the insider flagged. Outside that angle, shadows broke the curves into noise. Inside it, arcs linked. The geometry had a preferred reveal, like a watermark that only appears under a narrow light. Rocks don't choose their showtimes. Stakes escalate here. If you can stabilize a reveal at a fixed sun angle, you've either stumbled on an absurd coincidence of layered erosion and seasonal lighting, or you're looking at an engineered surface optimized for a periodic pass. And if the arcs are part of a lattice, they're not decoration. They're function. Action. We took the phi residuals and the 36-degree triaxial spacing and cross-referenced them against Patrick's Jupiter sphere nodal map. Not four identical shapes, different worlds, different skins, but for invariants, ratio families, angular separations, phase offsets. Two invariants matched, the triaxial 36-degree schema and a repeating 1 minute and 1.618 seconds separation pattern. The Jupiter map used them to route energy through storms without a single switch to flip. If Mars carries them, the lattice isn't a picture. It's a path. Impact, the geometry narrowed possibilities. Random geology fell away. So did most human-made debris theories. Nothing we've flown to Mars lays down 6-meter triaxial lattices. What remained was uncomfortable, a structured surface behaving like the visible edge of a buried machine. Counterargument closure. Pareidolia thrives on single images. We pushed for crossview. The insider pulled a narrow-angle MRO oblique from a different orbit. Different light, different season. The arcs were weaker, but the 36-degree intersections persisted within error. When we plotted centers, the grid deformed predictably with perspective, as if anchored below. Payoff T's. One hidden angle proved it's engineered, but geometry only narrows the field. Physics corners it, because if the lattice routes energy, heat and charge should behave like they know the map.